Whew. You see this one and it just doesn't make you want to do any form because it has decimals right away. Yeah. So I'm going to see what would happen if I factor those decimals out to start off with. Take out a negative 2.5. That would leave me with x squared. If I take a 2.5 out of 7.5, what am I left with? Plus, because a negative times a positive would be negative. 3x. And how many 2.5s are there in 10? 4 of them. Now what's inside the brackets looks much nicer. Can I factor that? Bracket, 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 bracket. To get an x squared, have to be x and x. To get 4, 2 and 2 or 4 and 1? What's going to make 3? 4 and 1. The 4 would have to be positive and the 1 negative to get the negative 4, and to make sure that my outside and inside make positive 3. That tells us what the x-intercepts are. The x-intercepts are x equals negative 4 and x equals positive 1. Because those would be the values that would make y equal to 0.
The good old zero product property or whatever it's called.
That is what it's called, zero product property. How do you find a y-intercept?
Plug in zeros for the x.
Plug in 0 for the x. As far as doing the math, I could plug in zeros where it's factored and figure everything out and multiply everything through. But can you see, going back to the original general form, it's going to be easier to do the math here if I plug in 0 for x? Because it's just going to be 0 minus 0 plus 10. So the y-intercept is 10.
So if it's negative 2.5x squared, does that mean it'd be negative 0 minus 0 plus 10? Thought so.
The nice thing about the factored form is you can find the axis of symmetry quite easily because it's going to be right in between your two x-intercepts. So what we highlighted on the other page, it says add your two x-intercepts together and divide by 2, and your axis of symmetry here would be negative 3 over 2. The x-intercepts will be what makes it 0. So there, I have a plus 4, so it's negative 4. I have a minus 1, so it's plus 1. Okay? As far as overall, if we can start picturing our graph, what we know so far is it has a y-intercept of 10, an x-intercept of negative 4, an x-intercept of 1, 1, 2, 3, 4, and an axis of symmetry at x equals negative 3 over 2. Wow, that looks bad. X equals negative 3 over 2 is our axis of symmetry. We already know that this parabola opens up or down? Down, because the a value is negative. So we have negative 4, positive 1, positive 10 as 3 points. We can still find the vertex. We'll have to probably go to our calculator for this. But since we know the x-coordinate is negative 3 over 2, you can plug that into the equation, either into the original one or into the factored form, and see what you get. I'm going to plug it into the original one. How much?
Scale's not working. Everyone's just dropping the candy off. So we clearly labeled ours and put it off to the side. Mr. Johnson's all business right now. This is bad stuff.
How much do we have in compared to like other people?
There was a mountain there. One girl brought in like a tiny little box for an entire class. But then when we got there, there was like this heaping amount. I don't know if it was one class or a combined thing. But
So if we plug in negative 3 over 2 for x, type that into our calculator. Now, at this point, since I'm typing it into my calculator, there are calculator functions that are a lot faster than this that can find the vertex that we've already learned as well, right? Normally, if you would have this kind of question where this is the best method, then plugging it in would have been a nice number to plug in so that this would be the fastest. But anyways, plugging this in gives me 15.625. That means our vertex is right here at negative 1.5, because that's 3 over 2, comma, 15.625. Now with that, we could draw our parabola, put arrowheads on the end to show that it goes on forever. That's something that's an automatic half-mark deduction. If you draw a parabola and don't put arrowheads on the end to show that it continues forever, you're indicating that your graph stops. So we always add arrowheads to our graph when we draw it. We got the coordinates of the vertex, we've got the intercepts and the axis of symmetry. We were able to factor this one. Questions you can do here are 3, 4, and 5. The axis of symmetry is right here at x equals negative 3 over 2. That is after I plug that value in for x, and I get y equals 15.625, that tells me the y coordinate of my vertex. Because the axis of symmetry tells you the x coordinate of your vertex. And plugging in that x value tells you your y coordinate of the vertex. Yes?
Could you also write it as 125 over 8?
Yes, you could write it as a fraction if you'd like. Yes. The dotted line is the axis of symmetry. It splits your parabola in half, so it's symmetrical on both sides. And that axis of symmetry is always, because it's symmetrical, right between your two x-intercepts. So when we find our x-intercepts, that's what we did here. We added our x-intercepts up and divided by 2, because that finds halfway in between them.
Wait, so what was homework for this one?
What's that?
What was homework for this one?
3, 4, and 5.